So second review problem, still trying to stick to solution chem kind of topics because they are from a long time ago and a lot of folks do get frustrated with these things. So different kind of situation, we're looking at a precipitation reaction instead, but you get some information here. So 3.455 gram sample of a mixture was analyzed for barium ion by adding small excess of sulfuric acid to an aqueous solution to the sample. So not all of that 3.455 gram sample is the barium ion. It is implied that it's a mixture, and so that's going to be important for what we do later. So resulting reaction produced precipitated barium sulfate, which was collected by filtration, washed, weighed, dried. Well, washed, dried, and weighed. So we care about the barium sulfate. You are told we've got 0.2815 grams of barium sulfate, but ultimately we want the mass percentage of the barium in the sample. So we want to look at the reaction that occurred here, try to work backwards and compare, what we have to the actual thing. So in this whole situation, we look at the general reaction that's going on here, and we don't know what else was in the mixture. The barium was there, and then also other things that happened to be soluble. So in the event that we don't really know what it is, we are just going to indicate this as barium ion. We have that, and this was reacted with the sulfuric acid, excess sulfuric acid, and sulfuric acid is a strong acid. We don't really care about the hydrogens in this case. So really, just getting the net ionic equation is enough here. So we have the barium sulfate is the product. And that's really what we care about. We know how much barium sulfate was obtained in this reaction. It's 0.2815 grams. So we want to work backwards. We want to think about what that means in terms of barium present in the sample. So we go back, and we have 0.2815 grams barium sulfate. And we're going to need to figure out how much this is in terms of moles. So quick conversion, 1 mole barium sulfate. I had this down somewhere, and I need to find that now. Let's see. All right, so 233.38. So not a particularly large amount of barium present here, or barium sulfate present here, but that's fine. So we end up with 0.2815 divided by 233.38. We end up with 0.0012 moles of the barium sulfate. So nice thing about this, if you look at the reaction at hand, you look at the precipitate, our ratio here, barium sulfate back to the barium itself, which is what we're looking for, is 1:1. So this also means within that sample there were 0.00121 moles of the barium ion there. And now we need to figure out the mass. We want mass percentage. I get that it's an ion. It's going to effectively be the same thing as just like barium as a solid. Those two missing electrons are not going to really change the mass a whole lot. And again, this was all locked into a solid structure anyway, so it means the same thing effectively. So we have our 0.00121 moles of the barium ion, which again we are going to treat pretty much just as if it were a solid. So barium's molar mass is, where did it go? At 137.33. So 1 mole barium, 137.33 grams. So we can do this math real quick. 0.00121 times 137.33, and pretty light. We end up with pretty small mass here, 0.166 grams, and this is purely barium ion. Just the barium present in that mixture that was there. But we need this information. We're not totally done with like 95%. The end question, the actual thing we're trying to figure out here is what is the mass percentage of the barium in the sample? And I don't know what just happened there, but something did. So we want to look at the mass of barium that we know is present there and what the original sample was. Mass percent is not hard, but a lot of people forget, like literally you are just taking the percent of the thing that you care about over the total. So this is where the 3.455 grams comes in. That's the overall. You know, that was the mixture, that was whatever the other soluble ion is present there. This is going to be our denominator in this case. So when we're looking at the mass percentage of just barium, so mass percent barium, we have the amount of barium we know to be in the sample due to the stoichiometry there. So that's the 0.166 grams barium over, let me just make sure my decimal is correct here, the 3.455. Of that total. And one important thing to make the point of, it's a really good thing that the mass of the barium is less than the total, because if it were not, we would get a percentage greater than 100, and this would not make any sense. So if you come across a situation where you're doing mass percent and you end up getting a percentage greater than 100, you probably want to step back and maybe look at your previous calculations and see, hey, does this actually make sense? So finish this up, solving the problem, make it a percentage, because you know it's going to be a decimal, so we want to multiply this by 100, and end up with 0.166 divided by 3.45, or is it 455 or 445? It is 455, good for me. So we end up with 4.8%. So there we go. So little percent by mass problem, not that hard a thing to do, but something we haven't looked at in a really long time. So just wanted to show this again. So and hope to see y'all soon. Take care and goodbye for now.